All right, so let's tie everything in together that we've been doing on the last couple of videos, and let's go around our unit circle again. The reason it's called a unit circle is because our radius all the way around this circle is 1. So anywhere that we want to drop an altitude and have a right triangle and talk about the angle measure from the center point here and the terminal side being up here somewhere, we're guaranteed that the hypotenuse of that right triangle will be 1. So the first thing I want to talk about is these quadrantal angles. Here we know that in the coordinate plane, if this circle has a radius of 1, then the coordinates to this point are 1, 0. And so we can talk about having angle measures of 0 radians and angle measures of 2 pi radians. They are the same. So we can talk about our exact values. The cosine of 0, which is the x-coordinate to this point, is 1. The sine of 0, which is the y-coordinate, is 0. And that's equivalent to the cosine of 2 pi, because that terminal angle started at 0 and we rotated all the way around this circle, and that terminal angle wound up right back where it started from. So that's going to be equal to 1, where the sine of 2 pi is going to be equal to 0. So we know that these angle measures are, although the angle measures are different, the cosine and sine ratios are identical for those. We talked about this the other day, that's equivalent to 90 degrees. The coordinates of this point, 0, 1, tell us that the cosine of pi over 2 has to equal 0, because that's the x-coordinate of that point on the quadrantal angle, and the sine of pi over 2 must equal 1. We didn't talk about angle measures of pi. The coordinates of this point are negative 1, 0. So we know the cosine of pi is negative 1, and the sine of pi is 0. Down here on this last quadrantal angle, where our angle measure is 3 pi over 2, the coordinates of that point are 0, negative 1. So the cosine of 3 pi over 2 is 0, where the sine of 3 pi over 2 is negative 1. So it still works out just like we saw for these angle measures on the surface of the circle in the middle of each quadrant. It's the same idea for the ones that lie on the axes. We still take the x-coordinate, and that is the cosine of that angle measure, and we take the y-coordinate, and that is the sine of that angle measure. So now we can fill out the entire unit circle with all of the exact values that we have everywhere around the circle. We can go all the way around it, not just at the 30, 60, 90 equivalents, but also at the quadrantal angles. And we can start out with a blank circle, and we can fill in every single value. I don't know what it is, but my technology just definitely doesn't want to work with me today. So we know the coordinates of this point. We found the coordinates of this point the other day. We said it was root 3 over 2. Come on, technology, you can do this. I know you can. The coordinates of this point were root 3 over 2 and 1/2. I can get this. There we go. Now it's going to cooperate. The coordinates of this point were root 2 over 2 for both x and y coordinates. The coordinates of this point were 1/2 and root 3 over 2. And I want to take a little side note here, and I want to have you notice something. For the non-quadrantal angles, for the ones that are in the middle of each quadrant, there are only 3 values that we have to work with: 1/2, root 2 over 2, and root 3 over 2. Those are the only three values that we're going to get for x and y coordinates at all these non-quadrantal points on the surface of this circle. And so let's talk about how we can remember which one it's going to be. Let's say I ask you, without you having the unit circle in front of you, let's say I ask you what the cosine was for 11 pi over 6, and you're like, I don't know, how can I find that? Well, here's a quick way to find it. Root 2 over 2 is only going to be used at some iteration where pi over 4 is the reference angle. That's going to be used here and here. The only thing you have to worry about is what quadrant are you in order for you to worry about whether your cosine and your sine are either positive or negative. We know that each quadrant, this is true for every point in that part of the plane. So that's all you have to worry about. Is it going to be positive or negative root 2 over 2? So those are really not going to give us a problem. The problem is going to come with 1/2 and root 3 over 2. And here's how I do it. I look at a right triangle where I drop that altitude for this pi over 6, and I look at the right triangle where I drop the altitude for pi over 3, and I compare the values of my x's and my y's. Notice here for pi over 3, notice how that cosine value is going to be smaller than the sine value. Here, cosine, the x-coordinate, has to be the smaller of those two values because it's a smaller measure, and sine would have to be the larger of those two measures. So I can just tell if I drop that altitude and draw my right triangle, I compare my x values with my y values. At pi over 6, I know the x value has to be the larger of these two values, and the y value, because it's a shorter measure, is going to have to be the smaller of those two values. And I can do that no matter where I drop that altitude. I can say, okay, the x-coordinate to this point is going to have to be smaller than the y-coordinate. So, and I realize I'm in quadrant 2, so even without reflecting this point, I can tell you the x-coordinate is going to be the smaller of the two values, and it's got to be negative. The y-coordinate is going to be the larger of those two values, and it has to be positive. And I can go all the way around this unit circle and fill out every exact value based on that relationship and the fact that there are really only three values I have to work with. Here the x value has to be the larger of the two. I'm in quadrant 2. It's got to be a negative value. The y value has to be smaller. So it's very easy to fill out your exact values table based on looking, is my x value bigger or is my y value bigger? Here the x value is bigger, so it's got to be the bigger of those two values of root 3 over 2. I'm in quadrant 3, so both of them have to be negative values. I know anything that is a iteration of pi over 4 has to be root 2 over 2. Here, if I drop an altitude, I know my x value has to be smaller than my y value. So even though it looks like a whole lot to remember, it's really not a whole lot to remember. Here my x value is smaller. Sorry, I'm on the positive end of the x-axis and negative end of the y-axis. Here I know that that's going to be positive root 2 over 2 and negative root 2 over 2 because I'm in quadrant 4. Here I know my x value is going to have to be the larger of the two. I'm on the positive end of the x-axis and the negative end of the y-axis, and I filled out the non-quadrantal coordinates very quickly by just realizing that there's only really two values that I'm going to be working with, and the relationship is that 1/2 is smaller than root 3 over 2, and all I have to do is pay attention to the sides of whatever triangle that I'm working with. So hopefully that helps you when it comes time to fill out your unit circle. And here's the unit circle completely filled out all the way around with all the angles, all the coordinates of the points. Remember, the x coordinate is going to be the cosine of whatever angle measure. The y coordinate is going to be the sine of that angle measure. Pay attention to what quadrant you're in. You know what that does to the negative and positive signs. Make sure that you know your exact values for all of those angle measures. We filled those out when we first started talking about radian measure, so that shouldn't be too terribly difficult. So if they want us to find all the trig functions for some angle measure, then all we've got to worry about is a reference angle. And 2 pi over 3 is over here in quadrant 2. Its reference angle is going to be over here at pi over 3. I know that if I drop that altitude for that triangle, that my x value is the smaller value, my y value is the larger of those two values, and then I know I'm in quadrant 2 where my x coordinate's negative and my y coordinate's positive. So it's very easy for me to find sine and cosine of any angle measure that they give me, especially if that angle measure has a reference angle that is some exact value in the plane. And then I'm going to use those relationships, those ratios, that tangent is sine over cosine, that cotangent of the angle measure is going to be cosine over sine, and then I can clean that up numerically. I won't take time to do it now. That cosecant of that angle measure is going to be 1 over sine, or the reciprocal of whatever sine was, and then I can clean it up because, again, for some bizarre reason, we've been told we can't have a radical in the denominator. And the secant of 2 pi over 3 is going to be the reciprocal of cosine, so that would be a -2. So it's very easy, knowing the unit circle and all those exact values, it's very easy to find sine and cosine, and therefore I can find all 4 of those other trig measures for any exact value angle measure. And so there they are. Those are all of the ones we found. They've cleaned them up algebraically, but that's what they look like. So that's something we'll definitely need to be able to do and need to be able to practice. Don't forget too that we have negative angle measures. So all we have to do is go in the clockwise direction, and that gives us a negative angle measure. So negative pi over 4 is going to be down here, and it's going to be equivalent to whatever my cosine and sine exact values are, but it's going to put me in quadrant 4. And here's what I know about quadrant 4. I'm on the positive end of the x-axis and the negative end of the y-axis. So I can pick up root 2 over 2 knowing that it's pi over 4, and knowing I'm in quadrant 4, and I can come up with the right signs to put with root 2 over 2 and get the sine and cosine, and therefore again work on finding tangent, on finding cotangent. The cotangent of negative pi over 4 is 1 over the tangent, so that would be -1. The cosecant of negative pi over 4 is going to be the reciprocal of sine, so that would be a -2 over root 2. And again, we can use some algebra. I'll skip a step or two in here, but it's gonna look like negative root 2 when it's all said and done, cleaned up algebraically. And the secant of negative pi over 4 is the reciprocal of cosine, and cleaned up algebraically, that's going to be positive root 2. So we can take what we know from sine and cosine and the coordinates of the points in the plane, and if it's the reciprocal relationships, we know how to find that. If it's tangent, we know tangent is sine over cosine. So what looks to be an impossible task is really not. The one thing that I would tell you that you do need to pay attention to is because tangent is the ratio